All right, let's talk about dilations. This is the transformation that we did not do when we did rigid transformations. So again, dilations is where something will change size, either get bigger or smaller, and it is not a rigid transformation. So it is a similarity transformation that turns the pre-image into the same shape but a different size. So we're not changing our overall shape, either getting bigger or smaller. The scale factor is what determines how much larger or smaller it's going to become. So if the factor is a larger number than 1, then it's going to get bigger. If it's smaller than 1, it's going to get smaller. That should make sense. Typically, you don't have a scale factor of 1 because when you multiply by 1, it's not going to get bigger or smaller, so it's not going to dilate at all. All right, so how do we do a dilation on a graph? We have a scale factor of 2. So we want our image, the thing we're going to dilate, the after, is going to be twice as large as the starting image, is what you have on the screen here. So the easiest way to do this is to take the coordinates that are the vertexes of each shape and just multiply them by 2. So in this case, we're going to get 4 and negative 4. We're going to get negative 4 and 10. And you're going to get negative 8 and 4. And so these will be the coordinates of the new shape. So 4, negative 4 will be A prime. Negative 4, 10 will be B prime. And C prime will be at negative 8, positive 4. C prime. And we will attempt to connect all these guys. Okay, so that's all you do. Take the coordinates, multiply it by the scale factor, and replot it out. Here our scale factor is 1/3. So I'm going to take my coordinate here is at 6. So 6 times 1/3 is just going to be 2. So this coordinate is going to come down to 2. 0, this is actually the coordinate would be 0, 6, right? It's actually 0, 6 times 1/3. Well, 0 times anything is still going to be 0, and 1/3 would be 2. Okay. This coordinate here is negative 6, 0, so times 1/3 is going to be negative 2, 0. And the same for the others. Pretty straightforward. And we can draw this new shape. So the new shape is 1/3 the size of the original shape. Okay. The origin, the scale factor is 1/2. So you can think about these. The new line segment will be half as long. It will be half the distance from the origin. So again, 3/4 times 1/2. It's going to give you 1.5, 2. And the other coordinate is 9, 6 times 1/2 is going to give you 4.5, 3. And then just plot those out, 1.5, 2. We'll call this A, so we can call this A prime. We'll call this B, so we can call this B prime. And there you go. That's the dilated shape. What you'll also notice is if these will kind of always make a straight line from the origin that it was dilated from. Okay, here, how do we find the scale factor? You simply take a coordinate from the image and divide it by the same coordinate of the pre-image. So in this case, let's just take this point A. It is -1, 2 is the image. So we'll just take the y-coordinate, 2. And the pre-image of the same point, the y-coordinate is 4. Reduce that to 1/2. And we say that the scale factor is 1/2. So in other words, the image, the pre-image, the blue one, times 1/2 gave us the image, the green one. It is half as big as what it started as. Okay, the scale factor for this one, pick any coordinate. I'm going to pick V because it's right on the line. So the image is, we'll just go with the x coordinate. It is 1, 2, 3, 4, 5. It is -5. And the pre-image is -2. So reduce those negatives will cancel, and 5/2 is the scale factor. So 5/2 is really what, 2.5 as well. So the blue one, just a pre-image times 2.5, gave you the green one. So the green one is 2.5 times larger than the blue one. What's the scale factor assuming the smaller shape is the image? So we went from the big one to the small one, from the big one to the small one. So let's take the coordinate, we'll just do x's again. The x coordinate of f is 4. But we need to see the image is the smaller one, so we need to go with 3. And the pre-image is the f, so that's 4. So the scale factor is 3/4. So the larger shape times 3/4 would give you the smaller shape. All right, so that's just a quick idea about dilations. We'll talk to you later. Have a great day.